We have learned how to add and subtract polynomials. The next logical step is to learn how to multiply them. Now, when you're adding and subtracting polynomials, you do not use any of the rules of exponents. For example, if we have a 3x plus a 5x, that is simply an 8x. There is no x squared. Alright, we will not use the product rule for exponents in an addition problem or in a subtraction problem. But we are now going to deal with multiplication. And when you're dealing with multiplication, that is when you're going to use the product rule for exponents. And a problem that commonly occurs is students having difficulty discerning when they should add exponents and when they should not. And again, just to sort of reiterate, the only time you add exponents is when you're performing multiplication. When the multiplication is finished, there'll be no more adding exponents. Now, when we want to multiply polynomials, I think it is reasonable to start with the simplest possible example of that type of multiplication. And the simplest example is going to be an example where we multiply the smallest polynomial possible. And that's going to be a monomial. So let's look at 6xy squared times a 3xy to the fourth. Now we are multiplying here, so the product rule will be used. Now, when you have more than one variable like this, you can actually work with constants and then one variable and then the next. And that makes the multiplication process a lot easier. So I will first go 6 times 3, which is 18. And then an x times an x. Since there's no exponent written here, I'm going to assume it to be 1 and 1. So I get an x squared, because I am multiplying. A y squared and a y to the fourth, when you add the exponents, is a y to the sixth. Alright, so that is your first example, a monomial times a monomial. Let's look at another one. We could take a 5m to the third n to the fourth and multiply it by a 2n to the sixth. Now the first multiplication problem was written using a dot to imply multiplication. The second one, we use the parentheses, but they still imply multiplication. 5 times 2, we'll do the constants first. That'll give us a 10. M to the third, and no other m's over here. This means m to the third. N to the fourth and n to the sixth, again using the product rule, is an n to the 10th power. So those are two examples of the simplest multiplication problems possible, monomial times monomial. Now if we step it up, and we're going to go one step further with the multiplication, we're going to have to use our distributive property. Distributive property basically says A times the quantity B plus C. When we distribute, we have an AB plus, distributing there gives us an AC. This distributive property is specifically for one monomial times a binomial, but of course it works with more than that, but that's where we will start. We will take a 3, even though it's just a constant, it is a monomial, times an x minus 4. And when we distribute, 3 times x is a 3x. The sign in the middle goes in the middle, and 3 times 4 gives us a minus 12. Now when you are using your distributive property, you have to be very careful with your negative signs. If I had a negative 4p being multiplied by a negative 3p plus 6, I'm going to have to use a lot of caution to get the rules of signs correctly. First multiplication will be right here, and you will do it just like we did our monomials times monomials. Negative 4 times negative 3 is a positive 12. P times p is p squared. A minus times a plus will give us a minus. 4 times 6 is a 24. And then there's the p. Let's try that one more time, but with a longer example. Let's take a negative 6a and multiply it by negative 3a squared plus a 5a minus 6. Now the distributive property specifically addresses a monomial times a binomial. But we can actually do more with it than that. My first multiplication is going to be right here. Constant out front times the leading coefficient. Negative 6 times negative 3 is a positive 18. A times a squared will be an a cubed. So the first multiplication is finished. Second multiplication is right here. Negative 6 times plus 5 is a minus 30, and a times a is a square. And the last multiplication will be right there. Negative 6 times minus 6 is a plus 36. No more a's here, so it's just the 1a from right there. And again, distributive property in action, monomial times any type of polynomial, and you can distribute as many times as is necessary. Alright? Now the next type of multiplication we will do, you can do a monomial times 2 terms times 3 times 4, and it's going to continue to work in the fashion we've already established here. We need to step up to working with something a little bit bigger than a monomial. We need to look at how you go about multiplying a binomial times a binomial. And the technique we use is something known as the FOIL method. Now the FOIL method is really nothing more but the distributive property in action. But the letters F, O, I, and L help you remember in what order to distribute, and they make sure that you distribute everything that should be distributed. F in FOIL stands for first times first. So we're going to start off with the 2x and we're going to distribute it. Distributing the 2x there gives me a 2x squared. That was first times first. Then we take the 2x and we distribute over here. 2x times 5 is a plus 10x, and those were your outer products. Now that the 2x has been distributed all the way through, I'll move on to work with the minus 3. Minus 3 times x is a minus 3x. That's an inner product, and that's what the I stands for. And to finish up with the 3, minus 3 times 5 is a minus 15, which was last times last. So the letters F, O, I, and L have helped you to remember what to distribute and what order it should be done. Now, unlike our previous examples, this one has a little bit more that needs to be done. When you use the FOIL method, it's very common for these two inner terms to be like terms. So the 2x squared comes down because there are no other x squares. A 10x minus a 3x, when combined, will give us a 7x. And there's the constant minus 15. Now note that when I was multiplying here, that is when, for example, x times x became x squared. In other words, that is when I used my product rule. But once the multiplication is finished, which it was at this stage, the product rule does not get used anymore. Neither do any of the other rules of exponents. At this point, it was nothing more than the act of combining like terms. Let's look at another one of those types of examples. Let's look at a 2n minus 4 multiplied by a 3n minus 2. Again, doing this using the F, the O, the I, and the L as a reminder. First times first. We're going to take the 2n and distribute it. 2n times 3n is a 6n squared. Notice me using the product rule. Outer product is the 2n times a minus 2, which is a minus 4n. Inner product, since I'm done with the 2n, I'm ready to move on and work with the minus 4. Minus 4 times 3 is going to be a minus 12n, and then a minus 4 times a minus 2. Minus times minus is a plus 8. Again, multiplication has been finished. I have no more use for the product rule. Now I combine like terms. Using the FOIL method has put the like terms together, and a minus 4 and a minus 12 is a minus 16n, not an n squared. We're not multiplying, we're subtracting and adding. And then the 8 comes down, and I've finished foiling. Alright, let's try one more example of the foiling. Let's take a 7x plus 3 and multiply it by a 2x plus 4. Again, try to do it with the foiling, which is, again, just the distributive property. And a helpful reminder, start off with the 7x and distribute it all the way through. 7x times 2x. 7 times 2 is a 14. X times x is an x squared. First times first. Outer product. 7 times 4 is a 28, and there's the x. We're finished with the 7x because it's been distributed all the way through. Now for the 3. 3 times a 2x is a 6x, and 3 times a 4 is a 12. Now to combine the like terms, 28 and 6 is a 34x, and there's your 12. So that is the FOIL method. First, outer, inner, last. It is the distributive property, but it helps you to remember in what order to distribute. And later on, when you have to learn how to factor, the FOIL method will come in handy there as well. And what factoring is going to be is a process where we take this answer and figure out what two binomials gave us that answer in the first place. And the FOIL method may not be readily obvious why, but the FOIL method will help us with our factoring later on. Now, when it comes to the FOIL method and multiplying a couple of binomials together, there's a couple of special cases we need to look at. And you really don't have to worry a whole lot about these special cases if you don't recognize them offhand, because even if you don't recognize them offhand, the FOIL method will still help you work them out. This particular multiplication is one that I often call difference of squares, not because of the way it looks now, but because of the way the answer is going to look once we're finished. Foiling again. Start with the 2x, start moving it through 2x times 2x, 4x squared, and that was your first times your first. Your outer product is a 2x times a 3, which is a 6x. Now we've distributed all the way through, we're ready for this term. Minus 3 times 2x is a minus 6x, and a minus 3 times a plus 3 is a minus 9. Note that when I combine like terms, a plus 6x and a minus 6x simply cancel, and you're left with the 4x squared minus 9. And this is why I called it difference of squares. You notice everything is a perfect square, the 4, the x squared, the 9, and it's a minus in the middle. And anytime you have this pattern, a plus b times an a minus b, you're going to find that the inner and the outer products cancel, and all you're going to be left with is the square of the first one minus the square of the last one. All right, let's look at that one more time. If I had a 3x minus 5 and multiplied it by 3x plus 5, if I was to FOIL, I know the outer and the inner would cancel. So if you recognize this pattern, all you have to do is first times first, which is 9x squared, that was here to there, minus last times last, which would be a 25. Again, noticing this pattern exists saves you a little bit of time with this particular multiplication. Now, if you are asked to multiply together two binomials that are identical, like a 4x plus 5 times another 4x plus 5, don't assume too much about what kind of pattern is going to show up. With something like that, you do need to go through the FOIL method. And by the way, on that last example, like this example, if you were to go through the FOIL method like I did up here, you'd get the same answer. You can try that for yourself and you'll see that it happens. Alright, but on this one, we're going to FOIL the way we should. They're going to multiply 4x by 4x, 16x squared. Outer product, 4x times 5 is a 20x. I'm done with this 4x, working with this 5. 5 times 4 is another 20x. 5 times 5 is a 25. When you multiply a binomial by itself, the main thing you'll notice happening is your inner and your outer will be identical, making it a little bit easier to combine your like terms. Now there is a formula that basically says a plus b quantity squared, which is what we had here, a binomial times itself. The formula tells us that this is a squared plus 2ab plus b squared, where this is your a squared. In this case, this was your 1, 2ab, and here's your b squared. If this formula doesn't make much sense to you, then anytime you're asked to square a binomial, if this formula is not completely rock solid for you, just write it down twice. Alright, don't try and square it in this form. Write it out twice. Do first times first, inner and outer, last times last. Combine your like terms, and you really don't have to worry too much about this formula. Alright, one last type of multiplication. If I had a binomial being multiplied by a trinomial, I'm going to use the distributive property again. But how many times? Well, 2 terms times 3 terms, that's going to be 6 times I'm going to have to use the distributive property. And you won't use a FOIL or anything special like that. It's just going to be a matter of distributing. So I'll start with the 4m, and here it goes. 4m times 4m squared is a 16m cubed. Next multiplication will be here. 4m minus 5m is minus a 20m square. And here, 4m times 6 is a plus a 24m. So I've taken the 4m all the way through. 1, 2, 3 times. Time to work with the 3. 3 times 4m. It's a 12m squared. I'm sorry, 3 times 4m squared. Next, 3 times a minus 5m. It's a minus of 15m. Last, 3 times 6 is an 18. So here are the 1, 2, 3, 4, 5, 6 fact multiplications that we promised. And now to combine like terms carefully. 16m cubed, that's the only one of those. A minus 20 and a plus 12 on the square is a minus 8m square. Combining like terms, that takes care of those. 24m minus 15m is a plus a 9m. Takes care of those. And there's only one constant. So even though you did 1, 2, 3, 4, 5, 6 multiplications, that ended up simplifying down into only 4 terms in your answer. And it's hard to predict how many terms an answer will have. You just have to do the multiplication. So let's try another one. Let's look at x squared minus 2x plus 3 multiplied by an x squared minus 4. Again, how many times am I going to have to multiply? Well, 3 times 2, that's 6 times. Let's start with this. X squared times x squared is x to the 4th. X squared times 4 is a minus 4x squared. So I'm done with that. Now the minus 2x. Minus 2x times x squared is a minus 2x cubed. Minus 2x times minus 4 is a plus 8x. So now, let me clear things up a little bit here. It's time to work with the 3. 3 times x squared is a plus 3x squared. And 3 times the minus 4 is a minus 12. And again, let's see what we can combine. X to the 4th is the only one, so that's finished. Minus 4x squared and plus 3x squared is a minus x squared. So that takes care of that and that. A minus 2x cubed, it's the only one. And a plus 8x it's the only x and a minus 12. So I've taken 1, 2, 3, 4, 5, 6 terms and condensed it down to 5. Again, there's no way to predict how that's going to turn out. So let's look at one last example of that type of multiplication. Let's look at an a minus b being multiplied by an a squared plus an ab plus a b squared. Again, how many times to multiply? 2 times 3, that'll be 6 times. Starting with the a. A times a squared is a cubed. A times ab is an a squared b. And a times b squared is a plus ab squared. Alright, finished with that. So let's go to the b. Minus b times a squared is a minus a squared b. Notice I'm keeping it in alphabetical order. A minus b times ab is a minus a b squared. And a minus b times a b squared is a minus b cubed. And again, let's combine like terms. There are no other a cubes, so I'm done with that. A plus a squared b and a minus a squared b cancel. A plus ab squared and a minus ab squared cancel. And then there's the minus b. Again, this time, an unpredictable answer, 6 terms, condensing down to nothing more than 2. So there are a few examples for you of multiplication with polynomials using the FOIL method and just using the distributive property.